AC through resistor. So here a resistance R is connected and a supply alternating voltage of V equal to Vm sin omega t is connected here. Accordingly, a current is flowing through this circuit and the current I, if you calculate, is found to be a function varying with respect to the AC voltage. Now, V equal to Vm sin omega t is the connected AC voltage, and therefore the instantaneous current I equal to instantaneous voltage by resistance. Therefore, this is equal to Im sin omega, this is equal to Vm sin omega t divided by R. Now this can be written as I equal to Vm by R into sin omega t, or I can take this as I equal to Im sin omega t. So I equal to Im sin omega t, that is the instantaneous current varying with respect to the voltage which is connected. So here in this case, Im is found to be equal to Vm by R. So the amplitude of the voltage variation will be always greater than amplitude of the variation in current. So another thing is that we got the V equal to Vm sin omega t, that is V equal to Vm sin omega t, and got I equal to Im sin omega t. So depending upon the value of this one, you can say that here the current and voltage are going in phase. Means the voltage increases, current is also increasing, and voltage increases, current is also decreasing accordingly. Therefore, the phase angle between the voltage and current in this case will be 0. Now, to represent this variation, voltage and current variation, we are now considering the phasor diagram. So, how to draw the phasor diagram for this particular case? So, let us start with phasor diagram. Now, to get the phasor diagram, let me first draw the variation of current and voltages. Variation of current and voltage. So, this is omega t. Then, let me split this into. Okay. Alright. This is pi by 2. This is pi. 3 pi by 2. Then 2 pi. So one complete cycle of AC. And I fix this as Vm. So this is the peak 0 and the same peak will come here. Okay. So I will be drawing the voltage variation like this. This is the sine wave of the voltage. This is actually Vm sin omega t. Now we found that the amplitude of the voltage is greater than that of the current, and therefore I will be taking the variation of current with amplitude little less. And and if I plot that current, it goes like this. Okay. So this is actually Im sine omega t. So this is actually the waveform of what you call the voltage and current. Instantaneous values of voltage and current is according to this. They go hand in hand and voltage becomes maximum, current also maximum on the positive side. Here current maximum, voltage maximum. See, they are going in phase, I could say. Now, to draw the phasor diagram compared to the waveform, actually we are representing the waveform with a rotating vector in 4 quadrants. Okay. To draw that, I will be taking the 4th quadrant. 1, okay, 4 quadrants, and let me assume a position or a phase angle omega t which is less than pi by 2. When it comes less than pi by 2, the whole drawings will come in the 1st quadrant. Now this is the position, then I will be drawing a line vertical parallel to the axis, y axis. So voltage will be meeting here. So this is the measure of voltage at that instant, measure of voltage. This is V at that instant. Then this V represented in terms of Vm. I measure Vm. Keep it over here and rotate it till it meets at this particular point. So I draw a line. This particular line is Vm. Then this angle is omega t. That is this angle. Then of course this will be your Vm sine omega t. So this measures Vm sine omega t. Now at the same instant the current is here. I measure that current. Yes. This is the current J, I at that instant. Then I can measure the peak value of current, that is this much. This is the peak value of current. I take that peak value and rotate that, and you can see it meet at this particular point. So this is actually Im. So this measures Im and this whole length measures Vm. And you can find that this Im and Vm falls on the same line because the phase angle between the two is 0. Now this is actually the phasor diagram for the AC which is flowing through a resistor. So when AC flows through a resistor, there is no phase difference between the voltage and current. They will be always in phase. So this measures Im sine omega t and this measures Vm sine omega t. Alright, this is Vm sine omega t, this one, and this is Im sine omega t. So understood how to draw the phasor diagram for the AC flowing through the resistor. Okay.